Very good afternoon, everyone. Welcome out to the session. Hope I'm audible and my screen is visible. If it is so, let me know that in the chat. Thank you, Abhishek and Naman. Okay, great. So we are left out with only few days for the sessions. So have some topics to complete. So let me move directly to the topic of this session. So until now, we have seen some of the features, okay, or else the concept that is used in this Java. So, and one of the important concepts that you have to be aware of is exception handling concept. So, what exactly this exception handling is? So, before mentioning about this exception handling, okay, I will mention some of the scenarios wherein, okay, the organization will look forward into. So consider you're working in a project, okay, of an application development, so product-based development. So in that, obviously, you'll be using thousands and thousands of lines of code. So for a example, just consider you are working on 3,000 lines of code. So you have created a set of execution for 3,000 lines. So it has its own logic and own codings. So you have it, and now you are compiling the code that you have, that is 3,000 lines of code. So consider, okay, there is an error at 84th line. So normally, if the compiler goes to it goes through each and every line, and if it has a error in the 84th line, okay, now this program stops abruptly and it will be moving out. That a error message will be popped out, and the compiler will get stops. So this is what happens. So now what you will be doing if that scenario as a programmer or a developer, so you will be again changing it. So according to the flow, okay, you will be changing it again, and you will be compiling the code, the upgraded code again. So in that case, what might happen? Okay, now this 84th line, okay, it has been corrected. So it compiles the rest of the code. So consider there is an error with some 505th line. So in that case, okay, it will again pops out the error and the program stops execution. So likewise, okay, consider there are 40 to 50 errors. So in all cases, okay, the error will be popping out, and there will be a termination of a program for 50 plus times. So this is what happens, and because of this, the efficiency, okay, of the programmer or a developer, okay, will get reduced, because it is a time consuming one. For each and every case, if you're verifying it, okay, it will be time consuming, and you cannot complete the project on time, because you might not be aware what will be the error that happens after you're correcting this particular set of code. So this also happens, okay, you not be aware of what happens next to, okay, if it is executing. So these are the actual situations that you'll be facing, okay, as a programmer or developer. So now, to handle these situations and make it more efficiency, so in that concept, okay, we are using this particular concept of exception handling. So now, in place of all those malfunctions, so we cannot exactly call it as errors. So errors are something that cannot be handled, and here it is a malfunction. So these malfunctions can be handled. That is like, instead of abrupt termination of a program, still we can ensure that this program can be executed after the malfunction too. So this malfunctions are always happens in runtime. So that is, runtime malfunctions can be handled, and that technique is called as exception handling. So these are not exactly errors. So these are errors that can be handled. That is, malfunctions can be handled. So now, as I mentioned earlier, so it is mainly used to prevent the abrupt termination of the program. That is, you're not supposed to terminate the program in the middle, because it is not the efficient way to use. So in that case, this exception handling uh, play a major role, okay, to ensure that the program is not terminating in the middle. So only it terminates when the complete set of program code is being executed. So that's what happens. So now here, if you take this exception, so we call it as like a throwable. So whatever the message that is coming out of this code, So that is throwable. So this throwable has two things, that is exception and error. So error is something like cannot be handled, and whatever we do, okay, and by using this handling techniques, we cannot handle those malfunctions. So and it has errors. So they have given example like a Stack Overflow that cannot be handled by using these things. So it has an error. But this exceptions are things like, okay, that can be handled, and we can skip to the next lines of code, so we can move it. So this is what happens. So now this is a basic thing that you should be aware of, why we have to use this exception handling. So now in this exception, we have three types, that is checked, unchecked, and error. So checked is something like, okay, that you can predict before the execution itself. So that is checked exception. So now if you are aware that this is going to give us an error or a warning kind of a thing, in that case, okay, you can use it in the exception handling technique, and you can get exactly the rest of the code can be executed. So that is like checked exception. But we know the most of the exception happens in runtime. So it is not aware by us, or else if the programmer or developer is executing the code, okay, they might not be aware of the exception that is happening in the runtime. So it happens a lot because the logic that we are using might be new, and the product that we are developing might be much complex. So in that cases, okay, we are not always sure that it might not throw an error or not. So it is not like that. So in that case, okay, most of the time this runtime exception occurs, and those are called unchecked exceptions. So that unchecked exceptions are ignored at compile time. So those are like arithmetic exception, null pointer exception, array index out of bound exception, and unchecked. So these are the exception types that we have. So now here, to handle this exception, we have keywords. So we know that we have to give as an input to the code so that the compiler can understand that there is an exception. So in that case, okay, these are the keywords that we can use. So before that, I have mentioned about this error, right? So error is obvious, that which cannot be handled. So that is mentioned as error. So to handle the exceptions, okay, we can use these keywords, that is try, catch, finally, throws, and throw. So these are the keywords that we can use to handle those exceptions. So try and catch, okay, I hope most of you are aware of it. What does try and catch? So these are like mentioned as blocks. So try block, catch block, finally block, throw block, and throws block. So try blocks is the block which contains the code that might go wrong. So that is like, okay, you consider you are not sure with the code that you are writing, which might throw an exception. So that is the condition or a situation that you have. So in that case, you can mention, or else you can type the code within the try block. So try block will not be always used alone. So that cannot be used alone. So you have to use the catch block. So try block is like, okay, you are trying to catch the exception within the code that you have written. So that is a try. So catch is like, okay, this catch block is used to handle that exception. So now from this try block, you'll get the exception, and to handle that exception, you're using the catch block. So this catch block is followed by the try block. And now what happens is like, okay, in this catch block, you will be using the exception, exact exception name. So now if you are aware of what exception it is exactly going to throw, in that case, you can use the exception name itself followed by any variable. If not, you can just go with only a term called exception. So in that case, it will, the compiler, it focus on what exception it is happening, and it will throw the output. So finally, coming to finally, so this finally throw and throws, you might not have used it. So finally, it's like, okay, now it follows the try and catch blocks, because so now we are not always sure whether the try block has the malfunction or not. So we might not be aware. And in the same case, okay, we might not be aware whether the handling technique that we have used is right or not. So this kind of situation also occurs. So we are not aware of all the things, right? So we might not know aware whether there is a malfunction or not, as well as, okay, whether there is exact handle technique used or not in the catch block. So what happens is like by using this finally followed by try and catch. So even though if there is any malfunction, okay, or not, this finally block will get executed and the rest of the code now get executed. So if there is malfunction and if it is handled, okay, finally block will executed and again the rest of the code which is present after this finally block will get executed. So even if it is not handled, so now consider we have a code in a try block and that has an exception, and in catch block we have given an exception that is not exact match to the exception that is happening in the try block. So in that case, okay, we know abrupt termination will happen. But this finally block will make sure that even though the code is not handled, okay, the rest set of the code will get executed. So this is the most important use of this finally. So even though if there is malfunction or not, even the malfunction is carried or not, okay, this finally blocks ensures that the rest of the code is being executed. So that is the most important feature of this finally. And throw and throws, that is like a similar one. So throw is a keyword that is to throw an exception, and this throws keyword is used to declare exception. So now throw is followed by the exception name and what exception it is exactly. So that is a kind of a thing that will be high in code. So I will show that exactly in the code so you can understand it better. So throw is like it used to throw what exact exception it is, and throws is used to declare what exception it is. So that is a thing, and it does not throw any error. So unlike throw, okay, throws does not throw the exception, and it specifies that there is an exception might occur in the method given, and it is like just a method signature that we have. So this is what with this keywords that we have, or else the blocks that we have. I hope you're understanding. If not, if you can let me know. So I'm explaining it in words, okay, instead of in programs. So now I will explain those with a set of programs, so you might understand more better. So now here we can see I have a few code, that is few lines of code. So in that, okay, I'll leave this try and catch. So just consider int data 100 by 0, and I'm getting the output system.print SOP print data. So now what happens is like, okay, 100 by 0 is there. So now we know 100 by 0, of course, okay, it has indefinite and infinite. So this is what we'll be getting. But while coming to this compiler, okay, if you are using any number that is divided by 0, it is an kind of error. So that is arithmetic error here. So it has to be handled. So this is a malfunction that has to be handled. So now if I'm not using try and catch block, so this particular set of code, that is after this SOP data, okay, we have SOP rest of the code that will not get executed because there is an error. So code stops abruptly here, compiling here. So with this SOP data, so it stops here. It will not go to the rest of the code. So now to avoid that, okay, we need the code has to be executed. So in that case, okay, I'm mentioning this try block and catch block. So inside the try block, I'm writing the code, okay, which might have an malfunction. And in the catch block, I'm mentioning what malfunction we have to handle. So that is arithmetic exception. So here, as I know it already, it is an arithmetic exception. I'm mentioning that's like arithmetic exception E. So if I mention like null pointer exception, so in that case, okay, there will be an error and the rest of the code might not execute. So that happens. So if you're aware of what exactly the exception is going to happen, so in that case, you can use the exact exception name. If not, just go with exception, that is EXCAPTAON. So in that case, okay, compiler obviously it looks for what exception is and it will throw what exception is going on. So as I mentioned, okay, there are different types of exception. That is arithmetic exception that exactly deals with this a number when it's divided by 0. And null pointer is like when I have assign, okay, consider I'm taking a string value. The string value that is yes is equal to null. So now I'm printing the length of the string. So SOP yes dot length. So in that case, I have already given the string value as null, but I'm trying to print the length of the string that I have. So in that case, it is a null pointer because already the variable is null, but I'm trying to do the operation for that null value. So in that case, it is a null pointer exception. So again mention this. And we have number format exception. So number format exception is like, okay, I have, okay, consider I have a string value as any name. So consider VIT. And now what I'm doing is I'm forcing, okay, I'm changing this into different values. That is like, okay, this can be changed into integer. So integer I is equal to integer dot pass in. So I'm using that. I'm converting this as string s value into integer value. So, but it is not possible because we already know that is a string value, it is an integer value. So it's both the format is different. So if the format is different, we cannot convert it. So this is number format exception. And one more important thing is array index out of bound exception. So now consider I have an array. I have created an array which has an indices of 5 values. So indices 5 is the maximum thing that we have. But while coming to output creation, so in that case, I'm printing the output of 10 indices. So we already know that we have used only 5 indices, but I want the value of 10, that is indices 10. So in that case, it is array index out of bound because it is the array index doesn't have this particular value and it is out of the boundary. So it is array index out of bound exception. So these are the few exception that occurs mostly. So here, this exception is handled. So here you can see. So you will be getting this output. So exception is in main thread java.long, and it is showing what exception is occurring. That is arithmetic exception, which is divided by 0. And now, okay, this exception is handled so that, okay, the rest of the code is executed. So SOP, rest of the code, so rest of the code itself, the output. So rest of the code is got printed out. So this is what happens. So similar to that, I have one more code. So let me know what will be the output of this. So same inside the try block, I have given a set of code which might have an exception. And while coming to that exception is being handled in the catch. So here we can see just I have mentioned exception. I am not mentioning whether it is a null point or arithmetic or anything. Just I'm mentioning exception. So the compiler throws exception. So let me know what will be the output for this. Okay, exception message. There is a division error after the loop. So, okay, Kumar, you have mentioned this. Great. So now we know that, okay, exception happens here. So that is for sure because we are using this 10 divided by I. So now if you look at this for loop that we have, so int I is equal to 5, I less than or equal to 0, and I, sorry, greater than or is equal to 0, I minus minus. So in this case, okay, initially the I value is 5. So now I value is considered for this 10 by I, right? So first case, what will be getting? This is 10 by I will be there. That is 10 by 5. So 10 by 5, that is 2. So again, this loop continues. Okay, again, I will be getting this 2. So then now the again the value is getting decremented. So decrementation, it is 10 by 4. So it will again moves to values. So 10 by 4, 10 by 3, 10 by 2, 10 by 1. So while coming to 10 by 1, it is 10. And now it is again getting decremented. So it is like it will goes to 0. So now I value is 0. That is 10 divided by 0. So in this location, this exception exactly occurs. So for the before values, that is 10 divided by 1, 10 divided by 2, 3, 4, 5. Okay, the exception does not occur. But now, okay, when the 10 value is divided by 0, in that case exception occurs, and that is where this catch blocks comes into play. So in this catch block, okay, we have this exception EX. So it will exactly identify what exception it is, that is arithmetic exception. So now exception message divided by 0 and arithmetic expression that is divided by 0. So now as we are not exactly using the exception name here, so it also use how exactly it has been handled in this particular case. So that is what happens. And at last, okay, the exception is now handled. So it will move to the rest of the code, that is after the loop. So now, until the question of exception happens, okay, the code will compile normally. So when the exception happens, then it moves out of the try block. And in catch blocks, okay, we'll be getting this output, and the rest of the code will get executed. I hope you guys are understanding. So now, while coming to this exception, we have different types of exception index. So now we have seen this try catch block thing. So we are just using try catch block index. So similar to that, we have multiple catch block index, nested type try index, finally blocks index. Okay, we have different indexes. So now, just now we have seen try catch block. So multiple catch block is like, okay, for a single try block, we can have for a single catch block. So here, I hope you can see it. Sorry. Here, I have a single try block that is, but followed by multiple catch blocks. So in a first catch block, we have arithmetic exception. In the second catch blocks, we have array index out of bound exception. And in the third, I have just mentioned as exception. So now what I'm trying to say here it is. So now for a single try block, we can have multiple catch blocks. So here what happens is like, so if one of the catch blocks is going in hand, okay, or let's, okay, it is exactly matching with the exception handling that as compiler is going through, in that case, that particular catch blocks will get executed. So if not, okay, the other catch, it moves on to the other catch blocks. Now, if I have something like, okay, some error, malfunction is happening with respect to a null pointer. First, it goes to the catch block, first catch block. So it has an arithmetic exception, so it will not execute. So second catch block has array index out of bound exception, so it will not execute. And while coming to third, it is an normal exception. So we are not sure what exception is, so that's why we're giving exception. So in this case, okay, this particular overall exception blocks will execute because, okay, the null pointer exception is not there, and the previous catch blocks doesn't have this null pointer exception handling technique. So it goes out to the overall exception, and this exception will get handled here. So this here, but in this program, we can see, okay, it has an array index out of bound exception. So first it moves to the catch block, which has arithmetic exception. So it will not occur exactly. So it will skip this exception block and moves to the second catch block, which has array index out of bound exception. So it matches and it can be handled here. So that is what we'll be getting as an output. So array index out of bound exception occurs and rest of the code. So, okay, this is about multiple catch. And here you have finally. So like, if you can understand what exactly the logic is, let me know what will be the output for this. Okay, Simon sorry, okay. Kumar asked a question. So you are asking about this print stack trace. Okay, that is simple. So in the previous examples that we have seen, so let me explain that too. So in this particular example, okay, here you can see, other than this exception, I have used a particular thing called ex.print stack trace. So now, what is the main purpose of this print stack trace method? It is actually a throwable method which exactly shows in which line, okay, this particular error or exception has been handled. So now if I haven't used it, okay, it shows me like java.lang arithmetic expression divided by 0. So that is what actually happens if I'm not using this method. So if I use this print stack trace method, what happens is like, okay, it obviously shows arithmetic exception divided by 0. And also it also shows, okay, in which line of the code, okay, exactly this particular exception is occurring and in which line of the code the exception is handled. So this is what happens here. So it shows that. So it is like a throwable method. We'll not be using it much. Okay, if we need exact location, in that case, we can use this print stack trace method. Okay, hope you are understanding. Yeah, of course. So now when it is a simple program, so in this case, we are not supposed to like it is mandatory to where exactly this thing is happening. But while coming to product development, we know there will be several lines of code. In that case, obviously it is much mandatory to debug where exactly the things are going wrong. So it is important one. Okay, fine. So give me a sec. I'll move to the program that we are discussing. So finally, program. So this is what we're about to discuss. So Simon, as you have mentioned, finally block is always executed, and the rest of the code. Okay, fine. So here we can see in the try block, I have something like 25 by 0. So that is arithmetic exception. Obviously, it happens. So in the catch block, we have null pointer exception. So now we can see there is a malfunction and it is not exactly handled. Okay, even though we have used catch blocks, so catch block has null pointer exception, but that is not the exact method of handling it. So there is a malfunction and not exactly handled. So in that case, obviously, the program should terminate. But here, as we are using this finally block, so in the finally block, we are going this SOP statement, which finally block is always executed. And now the rest of the code, that is SOP statement, that is rest of the code will be printed. So this is what happens. So by using the catch block, okay, it shows what exactly error is, and finally block is always executed, and rest of the code will happen. So it will, even though error is not handled, okay, it makes sure that it is returning what error it is, that is what malfunction it is, and then the rest of the code will get executed. So this is what happens when we use finally block followed by try catch. Okay, so until now we have seen this, what is exception handling and why majorly this exception handling is mandatory while coming to product development. So in that we have different keywords or else indexes. So how to handle these exceptions, and we have seen few indexes regarding that. I hope you understood. So if you have any queries, you can let me know. And if not, give me a sec. I will create that answer poll for the session. Okay, your attendance poll is in your chat. You can mention your presence in the poll. And still, if you have any queries, you can let me know. If not, thank you so much for coming. You can leave. Have a great day.